Hello, in this discussion we'll be continuing our last discussion when we was talking about reference angles and finding the exact values of trig functions. So I've already did a few of those examples informally. Well, let's make it formal here. So let's begin. So a reference angle, if theta is an angle that lies in a quadrant and alpha is a reference angle. Now alpha, remember, is between 0 to 90 degrees. So if you want to take the sine of theta, then it's either plus or minus the sine of its reference angle. If you take the cosine of theta, now remember theta could be any angle, but you have to find its reference angle. So the angle could be 543 degrees, and you want to take the sine of 543 degrees. If you can find where 543 is at and find its reference angle, you can find the value another way. So if you take the tangent of theta, that's going to be the plus or minus the tangent of alpha. And again, alpha is its reference angle. Now, the last three, I don't know why you really put that in there, but that's okay. You can. It's true. Cosecant of theta is plus or minus the cosecant of alpha. All that's true, but usually when you have to evaluate one of those, you just want to go ahead and do the other reciprocal one and then take the reciprocal later. For example, if I wanted to find the secant of pi over 3, secant of 5 pi over 3, then I really don't do that. What I'll end up doing is I'll take the cosine of 5 pi over 3 first, using its reference angle as a guide, and then once I find the cosine of 5 pi over 3, once that's done, I'll take the reciprocal of it. Whether it's plus or minus is irrelevant, but it's still, that's how it works. So I don't really memorize those last three, but if you want to do that, that's fine. But taking a sine, the cosine, or the tangent of any given angle is like taking the sine and cosine and the tangent of its reference angle, and it's either going to be plus or minus dependent on the quadrant where theta is lying. And that goes back to all students take calculus. All are positive in the first quadrant. The sine is positive in the second quadrant, so therefore cosecant is. Tangent is positive in the third quadrant, so therefore cotangent is. And cosine is positive in the fourth quadrant, so therefore secant is. So that's how that works. So here's the picture of what that refers to. That looks like something we've already discussed. So if you take the sine or the cosine or the tangent of theta, now theta is the pink angle, it's in the second quadrant. That is the same thing as taking the sine, cosine, tangent of that alpha, which is that acute angle there. That is its reference angle. Okay, so all you have to do is now understand, if you take the sine and the cosine or the tangent of alpha, it's going to automatically be positive because alpha is an acute angle. So it's going to be positive. But that doesn't mean sine, cosine, and tangent of theta is going to be positive. That is dependent on where theta is actually going to be. So in this case, the sine of theta would be positive, and because the sine of alpha is positive and you're in the second quadrant. Okay? But if you're taking the cosine of theta, then you'd have to find the cosine of alpha, but it would be negative, because this angle is in the second quadrant. So that's how you kind of keep it together. Alrighty? Alright, let's look at some more examples here. So using the reference angle to find the exact values of some trig functions. So let's look at the cosine of 135 degrees. Now the 135 degrees, its reference angle is 45 degrees. So take the cosine of 45 degrees, and that one you should not even have to think about by now. Cosine of 45 degrees is a square root of 2 over 2. But there's a negative in front. Why is that? Because 135 degrees is in the second quadrant. And since it's in the second quadrant, cosine is negative. That's why we slapped a negative on there. So it's negative square root of 2 over 2. Now, the sine of 630 degrees is the same thing as the sine of 270 degrees. And that's just because I just didn't want to deal with an angle that big. So I used a coterminal angle. So I subtracted 360 off of that and take the sine of 270. Now 270 is the negative y-axis. Remember, it's negative 90, 180, 270 is the negative y-axis. And since it's sine, it's the y-coordinate, and so it's negative 1. And that's something else. This one really doesn't use reference angles, because the reference angle would not be an acute angle. I'm not sure what the author was thinking here when he was putting this on here, because this one doesn't follow that same rule. It's the sine of 270 that is the negative y-axis. But you can still do it. It's just a little different way than the reference angle. It's just the y-coordinate. Remember, the sine is the y-coordinate. In 270 on a unit circle, the bottom part is 0, negative 1, and it's the y-coordinate, which is negative 1. So now, secant of 13 pi over 4. Well, again, 13 pi over 4 is large, much like the 630 degrees is on that previous example. So what I did was I subtracted 2 pi because I wanted to find a coterminal angle to that. So 2 pi is 8 pi over 4. So subtracting 13 pi over 4 minus 8 pi over 4, I get 5 pi over 4. That's a little bit more reasonable. So now secant of 5 pi over 4, well, 5 pi over 4 ends up in the third quadrant. So, so there is a pi over 4 as a reference angle. Now, secant at 5 pi over 4, you know, I think that is a mistake. It is a mistake because secant of pi over 4, that is positive, but 5 pi over 4 is in the third quadrant, and third quadrant secant is negative. So we've got a mistake here. So this should be negative square root of 2, not positive square root of 2, negative square root of 2. So secant of 5 pi over 4 is actually negative secant of pi over 4, which is negative square root of 2. So we have a mistake here. So because secant is negative in the third quadrant. Now, a tangent of negative pi over 6. Well, negative pi over 6 is in the fourth quadrant, so its reference angle is pi over 6. And so, but tangent is negative in the fourth quadrant. All students take calculus. So tangent is negative in the fourth quadrant. So that's why there's a negative in the front. I know it looks like I factored a negative out, but that's not what's going on. Pi over 6 is in the fourth quadrant. Its reference angle is pi over 6. And it's negative because it's in the fourth quadrant. And so the tangent of pi over 6, that's one of our special angles. And we should have memorized. And that's root 3 over 3, but there's a negative, so it's negative root 3 over 3. Okay? So you might want to write these down and also make the correction for that part C there, that should be negative square root of 2 instead of positive square root of 2. All right, and this summarizes this discussion here. Finding the values of the trig functions of any angle. If the angle theta is a quadrantal angle, draw the angle, pick a point on its terminal side, and apply the definition of the trig function. That was part B, actually. But if the angle lies in a quadrant, we find the reference angle of alpha of theta, find the value of that function at alpha. That's going to be one of our special angles, more than likely, and adjust the sign to be plus or minus of the value of the trig function based on the quadrant in which theta lies. So this is like, closing the gate after the cow got out on that, because they didn't really discuss that first bullet until now, yet they gave us that one problem on part B before that at sine of 270 degrees. So that one wasn't discussed at that point. And so the sine of 270 is negative 1. Here is where they discuss it. If the angle theta is in a quadrantal angle, draw the angle, pick a point on the terminal side, and apply the definition of the trig function. So it's on, the point is 0, negative 1, and that's why the value was negative 1. So, but if it's in any quadrant, the second bullet applies. You take it, you find the reference angle, you evaluate the trig function at that reference angle. It's going to be positive at that point, but then you're going to adjust the sign to be plus or minus depending on where the original angle theta is located. So you're going to find this video very helpful when you're doing this stuff all the way through this course. So this one is very important, and in this table right here is a very good thing to put down in your notes. So you might want to pause it before I shut it off right now, and so you can have this in your notes. So, but that concludes this discussion. If you have any questions, feel free to contact me, and you have a good day.